Greetings everyone. Today we're going to explore solving systems by substitution, but very specifically, we're going to be isolating a variable and we're going to have only special solutions in this video. So if you're in my class, make sure you're on the right piece of notes. If you're not in my class, make sure to check out my other YouTube videos. Now, in the last video, we would have already written this down, but we're going to recall our steps. Step 1, you have to pick a letter to isolate. You have to solve for a variable. Now, you get to pick. There is a strategy behind this, so make sure you're picking the easy variable. Step 2, you're going to substitute that expression you just found into the other equation and solve. Step 3, you have found one of the variables, but wait a second, Mortvet, you just said these are special answers. So guess what, you guys? We're skipping step 3 in this video. You're going to be done after step 2. That means this goes faster. All right, now because we have had a full lesson on this before, I might go a little faster. You'll notice we might have up to 8 examples in this video. So if you need to, let's say, do half of them or odds today and come back and do evens another time, please consider that. Let's start off with example 1. On example 1, we want to isolate a variable first. I'm going to choose the first equation. Do you see why? Get it? Why? Do you see why? Because I want to isolate y. Y is super easy to get by itself. You want to avoid fractions in my class. Oops, that's a 2x. And so I'm trying to teach you the easiest way. Isolate the variable that's easiest. See how easy that was? Step 2, you want to take the other equation and you want to replace, you want to substitute in for y. See how we isolated y? So when I write this, I'm going to write 6x minus 3 blank equals negative 12. In that blank, I'm going to fill in my expression, 4 plus 2x. Remember, as I've said in previous videos, that's the tough step, right? To kind of organize your thoughts in those letters. Now let's solve. This part isn't too bad. We're going back. We've done this a lot this year. We're going to distribute negative 3, make sure it's a negative. That gets us negative 12 and negative 6x. Next, we combine like terms. Oh, this is weird, you guys. What's 6 xylophones minus 6 xylophones? 0. They go away. They cancel. Okay, go through the steps though, right? Like drop down what you don't use. We have no letters. If we have no letters, that's special. That's special, you guys. So let's take a look. We've done this before when solving equations. Does negative 12 equal negative 12? Is that true? Yes. That means our answer, I'm going to write it up by the question, is infinite many solutions. Because it's true. What that means is I can pick any point and plug it in, and it'll work in this system. We have lots of options. That means if you were to graph these, they would be the same line. Now, see how we didn't have to do step 3? That's why today is going to go a little faster. All right, next example. Step 1, we want to isolate a variable. I think the second equation looks easier, and I think y looks the easiest because all I'm going to do is add x to the other side. That gets me a y equals 3 plus x. And you could even put a 1 if you want to. Step 2. Oops, I didn't box my answer though. Step 2, we're going to choose the other equation. So I'm going to pick the first equation. And where there's a y, I'm going to put a gap. In that gap, I'm going to write my expression. See how I substituted for y? I substituted for y, so now I'm ready to solve. Let's distribute first. 3 times 3 is 9. 3 times x is 3x. Everything else falls down. Next, we're going to combine like terms. Wait a second. Negative 3x plus 3x, that's 0. They go away. But I still need to see you drop down what you didn't use. Does 9 equal 4? 9 doesn't equal 4. That doesn't work. This is a no. What that means is if it's not true, it's no solution. Nothing works. And I need to see those full words written out. Example 3. Step 1, isolate a variable. I'm going to use the first equation and I'm going to isolate y because it's practically by itself. We're just going to add that 3x over quick and we get 1 plus 3x. Don't forget the box. Now, I'm the only teacher I know of that teaches this box idea, but I promise it helps you understand. Step 2, we're going to use the other equation, but where there's a y, I'm going to put a parenthesis. Now this one looks a little different. That's okay. Still follow the same steps. Instead of y, I'm going to write 1 plus 3x. Next step, we solve what we have. We tend to distribute first. That keeps happening. 2 plus 6x. See how I multiplied? Now, there's nothing I can combine on the left, nothing I can combine on the right. So next we're going to undo any addition or subtraction. Instead of a positive 6x, we're going to minus 6x. Wait a second, that makes both of them cancel. Do you see what happened there? Let's drop it down. I got a 2 and a 2. Does 2 equal 2? Yes, that's good. That's positive. Because it's good, that's our infinite many solutions. Make sure you write out the words. Example 4, let's isolate a variable. Now I'm going to stick to one color this time. That way it looks a little more like your paper. I'm going to choose the first equation because that y looks easier. To isolate y, I'm just going to kick that 5x over by subtracting it. Let's draw our box. Step 2. Instead of y, we're going to draw parentheses because it's y equals y. I'm going to change the y to a negative 5 minus 5x. I'm filling in my box. Next step, we're going to distribute. We get a negative 10 and a negative 10x. Everything else falls down. Ooh, that's a lot of 10s. Next step, combine like terms. 10x minus 10x. That cancels. There we go. But be careful. Negative 10 and 10. Is a negative 10 equal to a positive 10? It's not. So this is not true. So this one is actually no solution. So watch out for your signs. Those signs matter greatly. Example 5. Step 1. I think that this x looks the easiest. So I'm going to write the second equation, but I'm going to solve for x. I'm just going to kick this 6 over. So 3y minus 6 equals x. There's my box. Step 2, use the other equation, and instead of x, I'm going to write parentheses. So 2 parentheses minus 6y equals 12. And in those parentheses, I'm going to fill in 3y minus 6. Draw a line down the equal sign and let's get going. 2 times 3, 6y. 2 times 6, negative 12. Next step, combine like terms, 6y minus 6y. There's our cancellation that we're anticipating a lot in this video. Well, this is interesting. All the letters went away, and again, negative 12 equal to negative 12? No, that's not true. This is no solution again. Example 6. Ooh, we have some strategy here. Okay, let's think about this. I'm going to go back to colors. If you look at the first equation, 2, 8, and 6, all of those, 2 fits in. Okay. Second equation, we have 5, 20, and 15. Well, 5 fits into all of that. Okay. So let's see. I could choose either one. I'm going to choose the first one. 2x plus 8y equals 6. Remember my strategy. Choose smaller letter. I'm being very generic right there, meaning let's choose the x to get by itself. We're trying to avoid fractions. So instead of positive 8y, let's minus 8y. Next step, instead of times 2, we're going to divide every piece by 2. So see how they divide nice? That's because our strategy worked. X equals this expression. Step 2, you want to write the other equation, but where there's an x, I put my parenthesis. Everything else stays the same. Instead of x, I'm going to write 3 minus 4y. Let's solve. Distribute first. We get a negative 15. We get a positive 20y. Everything else falls down. Well, 20 yo-yos, subtract 20 yo-yos, that cancels. Let's see what falls down. Negative 15 and negative 15. Are those equal to each other? They are equal. That's good. So that means that my answer is infinite many solutions. Many solutions. I can write today. Oh my goodness. There we go. All right, next example. This looks interesting. There's a 0 there, but let's definitely choose that first equation because the y is almost by itself. If I isolate the y, all I have to do is subtract 2x. 0 subtract 2x is just negative 2x. That's my box. That's a tiny box. That means this is going to be easier. Step 2, choose the other equation, and where there's a y, I put my parentheses. Where there's a y, I put my parentheses. In that parentheses, I'm going to fill in negative 2x. Let's solve. I just have a single distribution. That gets me a negative 4x. Everything else falls down. Wait, that looks different. What's 4 xylophones minus 4 xylophones? Nothing. Normally I'd just cross off, right? But I need something, so I'm going to say 0. We're done. Does 0 equal negative 11? No, no solution. So even if it looks a little different, still follow the same steps, and it leads to no solution. Our last example. Let's take a look. I'm going to use the first equation. Look at that y. It's almost by itself. So we're going to minus 2x to the other side. That gets us y equals 7 minus 2x. Perfect. There's my box. Step 2, we're going to choose the other equation. You have to use the other. And where there's a y, I'm going to put parentheses. Where there's a y, I'm going to put parentheses. In those parentheses, I'm going to put what y is, 7 minus 2x. There we go. Let's do some solving. We're going to distribute a 2. 4x plus 14 minus 4x. Do you see how I multiplied there? Next step, combine like terms. 4 xylophones minus 4 xylophones. That's nothing. They cancel. So let's drop down what we didn't use. 14 and 14. Oh, does 14 equal 14? Yes, that's true. So we have infinite many solutions. It works out. Infinite many solutions. We're good to go. All right, I know that was a longer lesson. Make sure if you didn't do all of the notes today, you revisit the other ones before a quiz or a test. As always, let me know if you have any questions. Check out Google Classroom to see what task we have to complete with this lesson. And until next time, have a good one.